Good morning. So I'm just going to make a really quick video on what we did today in class. It is our live class for the week. It is Wednesday, January 13th. We need you to have out your packet. There are a few bell works we're going to do, and then a little logical reasoning puzzle. The other thing I wanted to point out is that the schedule is a little bit different this week. You're in week 19, and for the schedule, we do not have school on Friday. So the quiz that you guys are going to have is actually going to be tomorrow on Thursday, which is the 14th. So hopefully we're feeling good with that. I started off kind of just by asking if anybody had any questions. Email me if you do, making sure that you watched both of the lectures. So making sure that you watched periodic table trends notes number 1 and the electron configuration notes number 2. So if you haven't done those, this is probably not going to help you. So you might want to pause this, go back into the Monday and Tuesday folder and make sure that you're watching those. And then, like I said, this is Wednesday. This is live class. Inside of here are going to be your participation points. If you didn't come to class, you obviously missed those. So you need to find some time to meet with me tomorrow or later today to get those points back. So your participation points are here. And then the answer keys are also in here, and they are taking forever to load. My computer is extremely slow today. But the answer keys will be, I don't know where they are, but they will be here. Okay, for Wednesday's worksheets here. The other thing that we talked about was there is a lab video in the Thursday folder for tomorrow. All the bells. So we have the Thursday folder here. You do have a reactive series, so you can see one of the trends, and you can see that it gets more reactive as you go down the metals. We might have put a little too much of one of the chemicals in the water. But so everybody's safe. We had proper safety precautions and all that kind of good stuff. And then your quiz is actually going to be on Thursday. It is in the Thursday folder. Okay. Also on your homepage, it's over here as well. So, but you got to be ready for that for tomorrow because we don't have any school on Friday. As speaking of the quiz, let's talk about it. So Thursday's quiz is open from 7:30 until 1:30 on Thursday. It is 8 questions and 29 points. It is over the periodic table groups. So it's like, what are the halogens? What are the alkaline earth metals? Where are the rare earth metals? So you got to know those. That's from last week. You have to know periodic table trends. There were 4 of them. That was from Monday's lecture. And you have to know how to do the electron configuration reading off the periodic table. And so we're going to practice all of that today. Hopefully you're feeling good. So what I'm going to do, what I did now is I gave them a moment to go ahead and locate. You want to find in your packet electron configuration bell work, and you also want a periodic table so that we can read these together. Okay, so I'll give you a second here to make sure you have found the electron configuration bell work. All right, so hopefully you're ready. So you have your electron configuration bell work out. Let's do a couple examples. So the first thing, hopefully, that you guys were able to see during your, and I'm starting off with the harder stuff, this section, these first 2 groups here, the elements in here always put their electrons in the S-shaped orbitals. Okay, their last ones here. So that's the S block. Then for this happenstance, for this trend, technically good old little helium should be over in this block right here for this one, because he also puts his electrons in the S. Then, again, as a little refresher here, any elements over here put their electrons in the P block. Beautiful. Good enough for that. And then finally, the electrons down here are put into the D-shaped orbitals. So you would say they go into the D orbitals. And we're never going to go above barium for this trend. So we are all good here. Now, when you're reading these, you read that the electron configuration energy level is the period number. Then you read the shape. Then you read how many blocks in it is. Remember, the maximum for S is 2. For phosphorus, or for P, excuse me, it's 1, 2, 3, 4, 5. There's 6 maximum. And for D, 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's a maximum of 10. So you kind of just read it like a book. So might as well just do the first one. Let's go to PD here. Boop. All you're going to do is you're going to read it like you would read a book. So the first thing we have is energy level 1. So I'm going to write this, and then I have it typed so you can read it nicer. And then this first shape is S. And then how many blocks? So we're trying to get all the way down to here. If I was doing hydrogen, I'd just write 1s1. If I was writing helium, I'd just write 1s2. So 1s2. Now we got through the first energy level. Then we're at energy level 2. Shape S has 2 valence electrons. Gets me through to beryllium. Again, if it was beryllium, I'd stop there, but I'm trying to get to PD palladium. So I'm keep reading. I'm still in energy level 2. I'm in the P shape. 2, P, and 1, 2, 3, 4, 5, 6. Again, if it was neon, I would stop there, but I'm still going. Then we're in energy level 3. Then we're in S, because 3S has 2. Then I'm still reading like a book coming across here. 3P has 6. 3P has 6. Then I'm here in 4S has 2. 4S has 2. Then, just because it's geometrically closer, after 4S comes 3D10. 3D10. Then it pops back up to 4P6. 4P6. Heavens to Betsy Lou. I'm just going to keep reading. 4P6, 5S2, and then 4D. 1, 2, 3, 4, 5, 6, 7, and 8. So we should end in 4D8. There it is. Much neater that way. There we go. Okay. Perfect. So hopefully that's making a little bit of sense there. Hopefully you can go through and read some of this stuff. Oops, didn't want to take that off. Take out some of this messy writing so we can try it again. So, boop. All right. Let's try the next one. And I just, like I said, I was picking popsicle sticks. I was making students answer these for me. So hopefully you're feeling good. If you're not, you need, like I said, touch base with me. But if you are, I'm not going to do every single example with you. Let's do strontium. Let's just talk it through. Okay. We would read 1s2, which gives us for the first energy level, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, and then 5s2. That's where we would stop in order to do strontium. Okay, so you're going to want to go through, do the last 2 by yourself, and then check the answer key that's under this video, and hopefully you're feeling swell with that. You can also identify an element with its electron configuration. So as you can see here, 1s2, 2s2, 2p6, you really don't have to read all of that. The main thing that's going to tell you what element it is the last kind of bit, 4d4. So what I would do is I would go into 4, so it's 5s, but 4d, 1, 2, 3. We're looking at molybdenum for that one, little MO. Okay. 4p4, I'm going to show you a very common misconception. For P4, a lot of people sometimes go, oh, 1, 2, 3, 4p4, 1, 2, 3, 4. It must be tellurium. And that is not it, because be careful. P starts with a 2 because it's 1, 2, 3. So 4p4 is actually 1, 2, 3. It's selenium. Okay, because you remember the first energy level only has an S shape. So P starts on 2. So if you want to have your periodic table labeled, I highly suggest, I think we did this on the notes, but if you didn't, go ahead and write a couple of things that I would make sure I write is that the 3D drops here. The 40 starts with yttrium. and then 2p, 3p, 4p, and then 5p. If you have those, you probably aren't going to have a problem on the quiz reading the electron configuration. Okay. Then there is going to be some shorthand on the quiz. So the next portion beneath here, the shorthand is very simple. It doesn't even have the long part. You just read. This is the last bit. So 4D6. Again, 3D starts with scandium. 4D starts with yttrium. 1, 2, 3, 4, 5. That bad boy is going to be rubidium. Okay. 2P2. All right. 2P. 1, 2. That's carbon. Be careful not to call it silicone because remember you start with 2p, not with 1p. 6s1. 6s1 is going to be cesium, so on and so forth. You also will want to know how to do the shorthand, which is exactly the same. It's just the opposite of what that was. You look at Ag, and Ag is in 4D. 1, 2, 3, 4, 5, 6, 7, 8, 9. 4D9. ZN's short number here. Where is the end? And that's going to be in 3D10 shorthand. Let's do another harder one. Nitrogen. Sure, you can do xenon. I know you can. Nitrogen here. You're in energy level 2. Shape P, and you're 3 in there. Oh, oops, I gave the wrong answer. 5P6 for xenon. Okay. All right. So hopefully you're feeling good. Hopefully you can do those. You will see this on your quiz tomorrow. Then the only other second to last thing that we did was we had your bell work number 2. So if you don't have your periodic table near you, if you want your notes near you, that's fine. So pause it if you want. If not, we're going to go through a couple of these. The first one talks about the size, the first 2, I should say, talk about the size of atoms. So let's refresh ourselves and talk about what the size was. Remember, the atoms get bigger as you go down the periodic table, and that is on both sides. So don't think that it's just because there's only one trend that goes up and down on different ways. So bigger elements are always at the bottom, and smaller elements are always at the top. Wonderful. But then going across, remember, it gets smaller as you go across, and it gets bigger as you are on that side. Awesome. So they get small to large. And then which way would it be from you? Big to small? I don't know if that's this way, going across. I can't tell if my camera is flipped or not because I can't see the screen. So the first 2, what it wants you to do, if you're holding your paper for you, it has these 3 examples it would like for you to compare. It wants you to compare cobalt, which is right here. It wants you to compare krypton, which is right here, germanium, which is right here, and then calcium, which is right here. So it wants you to write it smallest to largest. So which one is the smallest? Good. This side. So it would go krypton, germanium, cobalt, and the largest would be calcium. So hopefully you're feeling good with that trend. The reason why it gets smaller as you go across is because the nucleus can pull harder on the electrons as you go across the periodic table. As you have more positives and negatives, it becomes a bigger pull, so they can actually flex the size of that atom to make it smaller. Okay. And then let's talk about going up and down. So we have iodine, bromine, excuse me, fluorine, and whoop. All right, so it has iodine, which is one here, bromine, which is here, and fluorine, and then astatine, which is here. So again, it wants it smallest to largest. So we know the smallest is on the top because they get bigger going down. So we'll go fluorine, bromine, iodine, and then astatine. And why is because you get more and more electrons as you go down. So fluorine here only has 9 electrons, and then the next one has 17 electrons, and then 35 electrons, and then bigger, then you finally have 85 electrons. So it just gets larger as you go down the periodic table. Okay, perfect. So you will do some comparisons in your quiz tomorrow. We'll try to make them a little bit more challenging, see how that goes. So for instance, if you wanted to know the difference between aluminum and an indium, which one's bigger? So why don't you take a look on your periodic table while I clean this up. Aluminum and indium. Let's do that. Aluminum is right here. Indium is right here. It wants to know which one is larger. Good. They get bigger as they go down. So you would say indium. What's bigger, magnesium or calcium? As I'm giving away answers here. Magnesium versus calcium. Those are up and down. I want a side-to-side one. Let's see. Let's see. Sodium and aluminum. I'm going to do D. Sodium and aluminum. Sodium is here. Aluminum is over here. Which one is bigger? Remember, they get smaller as you go across. So sodium is going to be larger on that one. Perfect. So what I want you to do is make sure you can go through. Make sure you can do these before your quiz tomorrow. The next part was please write the name of the group or the section of the periodic table in which these following elements are located. So I'm not going to do that for you because there's only one of each. But so for instance, titanium, what you would do is you would take a look here and you would say titanium is in this group. All right, back. Titanium is right here. And hopefully you know that those are the transition metals. So remember, we have the alkali metals, alkaline earth metals, transition metals, rare earth metals, halogens, and then the noble gases. So find the element and tell me which section it's in. You will have to be able to do that on the quiz tomorrow as well. Another thing that's not on here that you do have to be able to do with the quiz, I didn't put a review section on here, I don't think. You do have to know what would make a positive and a negative or a neutral ion. Remember, the metals are on this side. The metals tend to become positive or cations because they give away, their electrons. So they like to be positive. And the nonmetals tend to be anions because they take those negative electrons. And then what would be neutral? Well, remember, the noble gases never react. They don't take electrons. They don't give electrons. They don't react. They don't get a charge. They have all the electrons that they need. So those would be neither. Okay, awesome. Then back to our worksheet. What is the trend for reactivity in metals and non-metals? Remember, now this is different on each side. On the metals side, well, so first let's talk about reactivity here. On the metal side, the most reactive metals we have are group 1. They're insanely reactive. If you watch the short video in Tuesday's or Thursday's folder before your quiz, you can see we're actually going to throw some of these metals in water. One of them we might put a little too much in. It's okay. But so these, if you ask, are what are the most reactive metals that we have? Those are the alkali metals. Now, as a trend on the whole metal side, metals get more reactive as you go down the group. Okay, so the most reactive metal that we have is in group 1 at the very bottom, which is francium. Okay, perfect. So metals get more reactive as you go down a group, and the alkali metals are the most reactive metal group that we have. So anything compared to an alkali metals always win. The trend in non-metals, though, is, again, noble gases are left out of this. They never react, but we get more reactive as we go up the group on the non-metal side. And the most reactive non-metals we have are the halogens. So halogens win on this side, and it always goes up the group on the non-metal side. More reactive here. So the most reactive non-metal we have is not helium. You guys saw we did the balloon and it didn't blow up. It just popped. Fluorine, is the most reactive non-metal. Okay. Perfect. So then what you're going to need to be able to do is you would need to be able to tell me which one's more reactive. So we're going to look, for instance, at chlorine and fluorine, if you will. Let's get a fresh one here. Chlorine and fluorine. Chlorine, fluorine, which one's more reactive? Well, again, they get more reactive as you go up. So fluorine would be the more reactive one on that guy. How about magnesium and neon? Maybe that one's trying to be tricky. Magnesium and neon. Magnesium is here. Neon is over here. How are we even going to compare those? That's just trying to be rude because neon never reacts. So anything is more reactive than neon. So let's have you guys do magnesium. Down here, krypton or argon, those are both noble gases. So again, just trying to make sure that you know that the noble gases do not react. So you're just comparing reactivity. And again, more reactive as you go down on the metal side, and alkali win all the time. More reactive as you go up the non-metal side, and the halogens always win on that side. Okay. Now, the last thing here on this bell work, it says, how do you identify the number of valence electrons? That was also one of our trends. And remember, all you have to do those is you just have to look at the group number. So very simple. How many valence electrons does phosphorus have? Whoop, that would be 5. How many valence electrons does calcium have? Whoop, that would be 2. The only exception is good old helium. He does not have 8 valence electrons. He only has 2 valence electrons because he only has 2 protons. So, and he's filling the first energy level S, which is happy with 2. So hopefully you're feeling okay with the bell work here. The last thing that we gave them to do is a little bit of a puzzle. It will help you. So again, you want to do this and check the key. The key will be in the Wednesday folder right underneath this. The last thing is a logical reasoning puzzle. This is kind of just a fun little way to practice your trends to make sure that you understand them all together. So I'm going to kind of help you out and get you started in seeing how this works. So we have 26 elemental spots. They are just going to have a letter of the alphabet. Happens to fit perfectly there. And then it's telling you, remember, groups go up and down, that these elements go together in a group. They might not be the right order, but they tell you what go in a group. So you would say Z, R, and D go together, but it might be D, R, Z, or R, Z, D, or whatever. So you go through the different examples or the different clues to tell you where these letters go. So it's, for instance, it says S is an alkali metal. So I know S, P, I, and F are going to go here. So what I usually do is I draw here and I go S, P, I, and F. I don't know what order they go, but I know they go in there. And these are just made up elements. So it's not like sulfur, phosphorus, iodine, and fluorine. This is just a made up kind of periodic table here. So you can see that I finished clue 1. U has a total of 6 electrons. So we're going to say 1, 2, 3, 4, 5. Ooh, there's U goes here. Now, what I can also do is I know that G and N must also be in this group. Beautiful. I is the most reactive metal of any of the elements here. Well, I know that I is in group 1 because those are the most reactive metals. And if it's a metal, the most reactive must be at the bottom. So I know that that must fit right in there. And then I got rid of I. Awesome. Let's see. O is a halogen. So halogens are right here. So I know that W, O, and V must be in this group. Z has 3 valence electrons. So Z, R, and D. 1 valence electrons, 2, 3, aha. So Z, R, and D must go in here. And so you're just going to go ahead and finish these in, make sure your trends. For instance, W is the least reactive nonmetal in its group, so I know that W is over here. Remember, nonmetals get more reactive as you go up, so that means that this must be down here. Okay, so you're just going to go through. I'll tell you the most where everybody misses. When you're doing energy levels, 1, 2, 3, 4 for the S. And remember, this is 1s as well, where people get confused. This is the p orbital here. And remember, it starts at 2, 3, and 4. So I'm telling you, this is where people get 14 and 22 confused. So when you check the key, if you get that one confused, think back to how you're reading your electron configuration. Okay, so that is what we did in class. Hopefully you're feeling swell, and then you understand your trends. Let's go back here and go over what is on your quiz tomorrow. Periodic table groups, I'm talking about halogens, noble gases, things like that. Periodic table trends, the 4 of them: size, reactivity, group number tells you the valence electrons and which ones become cations and anions, and then being able to read the electron configuration off of the periodic table as well. So if you feel good with those things, you're ready for your quiz tomorrow. It will be open from 7 until 1:30, and depending on whether you're honors or regular, honors has 8 questions, regular you guys have 10 questions. So hopefully you're feeling good, and let me know if you have any questions. If you missed class and you need your participation points, let me know when you can meet. Thank you guys.